In this video, we will be, I'll be showing you how to create a isometric procedural world. Basically, we're gonna make this. So I'll be showing you how to create a procedural world generated using the Perlin noise. So as you can see here, this is a default or basic tile. You can change this to a grass or something like that. That is sand, and that is a water tile or ocean tile. So in a video game, you would, if well, depends on your game. You may, let's say you want to have a building on different kind of tile, or you want, let's say, to manually manipulate each tile. For example, sand tile, let's say you want to add, let's say you cannot build a building there, you will have to check for each tile. And using this procedural world is easier for you to generate a large amount of tiles that is controlled by the player or the program itself. So what is the Perlin noise? So this procedural generated world is based on the a noise. What is a noise? A noise this. Perlin noise is basically this. Right? There are many different type of noise. Perlin noise is basically a noise generated to create black and white dots. So using this, what we have here, let's say if you look closely to the image, if you pick one pixel from there, that pixel has a value between 0 and 1. Using the value between 0 and 1, let's say 0.1, we can determine what kind of type we will be using based on that. So let's go to the code, right? So let's quickly have a look of the function. So here at the start, we generate the world should be 10 by 10. No, actually it should be 20 by 20. And here in the generate function size x, let's ignore that for now. Generate is just the output. So here's the main function. So here on each iteration, we generate a noise using the Perlin noise. Perlin noise, let's see this image right here, and then we manipulate the value. So the seed, let's say you want to share the same kind of generation to other player, you can set the seed to that, and then you will have the same map. Seed determines what uniqueness of the generation will be. You can use it to control that. And x, which should be the noise x position, is basically the value determined by x divided by the size. Why we want to do that? If we just use the regular x and y, the map would be different. So here, let's take a look. Using different value has a different output. Using that divided by the size of that, compress the value into a center. So let's say sand would be compressed down to be around there, and that would be close by. So so here there is a very good block by, where's it? No, password. No, where is it? Here. So redblobgames.com is very good resource for this kind of information. So here again we determine this, the x value and the y value using this type, this code right there, except we don't subtract by 0.5. This is a very good blog post. I would recommend you to check it out. And then again here, if you go back, where is it? Here. So on each iteration, we generate a noise, which would be basically the x and y value. Let's change to nx and ny. The x is the starting position. So here, say we want 10, the size of the map. We want to subtract that. No, not subtract that. The size x is used to be generated to the extent to the right. So here, if you don't have that right now, it will just generate like so, since the x value is actually greater than the y. So here on each x, we will push to the right. But then for the y, if you look at the differences of that, 10 and 9, negative 9, 0.5, the differences is much lesser than that. So we want to extend it twice. But anyways, if you play around, you will get a better understanding of that. So twice we want to increase the size to the right. So it should be right there. Oh, right there, yeah. To the left and then to the right, like so. And then in this piece of code, so this basically the base. If we remove this, you will see the difference. So here we generate this, and keep going on until we reach to the point, and then the missing iteration right here is what fills out the missing pieces. So here, since this is an isometric world, that's why we need both to be filled out. Like so, and then just space for that, and then yep. Okay. This is not probably the best solution for a production environment, since there are many game objects which is not optimized for a very large map. What you may want to do is you may want to create a plane, 3D plane. So like that, you bring that 2D, that, and then let's rotate 90. Can we see? Let's go to 3D mode, right? And then 90. Oh, what's it? That's that. Hit X. Can we see it? Oh no. Okay, it should be negative. Okay, there you go. So normally what we want to do is we want to generate each tile on this. So if we rotate this 45 degree, okay, 90. What? Okay, we want to 45. not 45. This is 60. Yep, there you go. Yeah, like so. Wait, let me see. Basically, we want to generate each tile onto the plane, right? So use it as a texture. So then we're gonna have one large piece of map like that instead of having a multiple tiles. This will increase your performance by a lot. Um, but I will be I won't be covering on this video, but that's just a better way to do it. Um, yeah, let's go back, take a look at the script. So again, what we have here, generate function, just output is generating size. We just want it twice, a bigger, large map in X, and then we have a style value and a Y value, which should be, we can just say negative. So we start on the left instead of the center, which is 0. We want to start on the way left and then keep to the right. And again, same for the Y. Y will be up, no down, and then going up. And then the seed number we just determine on what if you want to share with another player or the player wants to share it with another person, they can use the seed number to generate the same type of map. So just keep just that, yeah. And here we generate using a Perlin noise. Is a value between 0 and 1. We determine the value of that, create tile add function. We take all that in, we check the noise value of that. If it's less than 0.2, we want to create a water tile. If it's less than 0.3, we want to create a sand tile. We should instantiate tile right there, and then finally we just set the position to the X, Y, and the Z, and then we set the final position, update the position of the game object. Right, and then the set index would be the set value. Why we want to do that? In 2D world is the best way to sort your items, which should be on the top and the bottom. So if you look at the 3D view, you will see that each tile has different set position based on where it is. So here it is actually behind that, and then as you can see, everything here would correspond to each. I mean, if you look at the 2D view, it looks like that, but 3D is different. So if you want, when you work on the project later on, you should keep in mind that this tile should not move, right? If it were to move, it should be the same. Let's say you want to replace that tile, you should remove the game object or something and then change it. But again, if you want to make in a production environment, it would be better if you have a large piece of plane, set not yeah, set each mesh and not the texture of each slot to each different tile based on your based on your noise, and it will be the same. The result would be the same, but it would be much optimized, and so you can use that for to improve your game a lot. Um, anyway, so the concept is simple. Again, we use a noise to generate by checking the value of the noise. Here, again, this website, a blog, is very useful if you want to generate a complex world. So here again, yeah, it's very useful. I use this a lot and I learn a lot from this. So I recommend you to check it out. But the main idea is that noise, or in this case, in our case, Perlin noise, is basically a texture mapping idea where you generate a value using a magical function, which generates the value between 0 and 1. We determine the tile type using differentiate the value. So let's say 0.1 would be the water tile or like that, yeah. But to create a much complex or perfect result would require you to adjust a value. So again, for my case, or for this case, we we divide the x value of the tile by the size. This would condense down the x position, and so it would, it would be like this. It would be more like an island. Let's say if that's not all the way be like that would be deep water. Then yeah, the the noise basically what you have to do to create a perfect result or your desired um, result would require you to play around a lot. I mean, even for me, if I want to change it to something else completely, I would probably have to create a testing scene and then try to change or make a different result value just to have a look at how it will be generated. But anyways, I hope you learned something from this video. Thank you for watching, and I'll see you again. Bye.